This video covers solving quadratic equations by completing the square. So these are the steps to complete the square. The first thing we want to do is isolate the constant term. So if we have our quadratic equation that looks like this, that's the constant term. So we need to basically move this constant to the other side. So isolate it. Then we need to make sure that the coefficient of x squared is 1. So this number right here, that needs to be 1. If it's not 1, we're just going to divide it out, which I'll show you. Then you need to memorize this formula. You need to find b over 2 squared. B is the coefficient of x. So take b, divide it by 2, and then square it. Or it's equivalent to just taking b, multiplying it by 1/2, and squaring. It depends on the problem. Sometimes the second way is easier. Then we're going to factor our perfect square trinomial. And then we use the square root property that we used in the previous video. So you might want to write down these steps, but make sure you memorize this formula because you need to use it every single time. So we're going to start with the first example. We would like to solve by completing the square. So here I have my a value, right? The coefficient of x squared, that's equal to 1, so that's good. We do need to isolate our constant term. The constant term here is 3, so we're just going to subtract that from both sides and we have it isolated. I left a little bit of space here because we do need to add to both sides of the equation. So I've isolated the constant term. The coefficient of x squared is 1. We're looking at step 3. We have to find b over 2 squared. So b in this case is -8. So just off to the side, you need to find -8 over 2 squared. You can write it out or you can just calculate it in your head. We have -4 squared, so that's equal to 16. Okay, why are we doing this? Because you're going to take 16 and add it to both sides of the equation. So 16 needs to be added. So the reason that we can actually do this is if you add the same number to both sides or even subtract, right, the equality of the equation's still true. So the equality is still fine. The reason we're doing this is because now the left side, this trinomial, is a perfect square trinomial. A perfect square trinomial can be written as a binomial squared. We know how to factor this. If we were to factor, we get x minus 4 times x minus 4. That's the whole point of completing the square because you will get the same binomial and then we can write it as x minus 4 squared and then you can use the square root property. So that's the whole idea. Complete the square, get this number, in this case 16, that makes the trinomial a perfect square, and then we can use the square root property. If you look at the trinomial, the original problem, that is not factorable. And so because it's not factorable and it's not a perfect square trinomial, we can't use the square root property. So that's why we're completing the square to get that value so that we can use the square root property. So I can write this as x minus 4 squared is equal to, right here, I'm just going to subtract so we get 13. At this point, you're going to use the square root property. We just take the square root of both sides. This goes back to the previous video. So I'm just going to move over here. So we take the square root of both sides, and we're going to get x minus 4 is equal to plus or minus square root of 13. I can't simplify square root of 13, so all we can do here is solve for x. X comes out to be 4 plus or minus square root of 13. That plus minus needs to be in between the two values. And then we are done. So that's our final answer. So that's the whole process of completing the square. Let's take a look at a few more examples. And we're going to have our steps here next to us. Okay. All right, so same exact steps. Isolate the constant term. Make sure the coefficient of x squared is 1. Find b over 2 squared. Add it to both sides. Factor. Use the square root property. All right, so right here, coefficient is 1, so that's good. I need to subtract 6. So you might want to pause the video, use your notes from the first example, see if you could do the second example, and then come back and check your notes. Or you can watch this and then try it on the third example. But first isolate, and so that's going to give me x squared plus 2x, leave some space, is equal to negative 6. And then again from here we have to find b over 2 squared. In this case b is 2, so that's 2 over 2 squared. That comes out to be 1. We're going to add it to both sides. And then the next step is to factor the left side. Remember, that's a perfect square trinomial. So if you were to factor, you get x plus 1 times x plus 1, which is x plus 1 squared. And then on the right side, we're going to get negative 5. Then we need to use the square root property. So we just take the square root of both sides. Remember, you need to include plus minus. This will come out to be imaginary, so I can simplify this a little bit. And we can also subtract 1. And that is our solution. So remember, this is really two solutions in one, negative 1 plus and negative 1 minus. Okay, so we can write it this way, or we can separate the two solutions. Keeping the steps in mind, let's try the third example. So this one's slightly different because the middle term is not divisible by 2, and so then we will end up with a fraction, but that's okay because we know how to work with fractions. So let's see. Coefficient of x squared is 1, so that's good. I need to subtract 5, move it over to the other side. So I have that. Now b is negative 5. So I'm going to write negative 5 over 2 squared. And that's going to give me positive 25 over 4. This is what we need to add to both sides of the equation. So in this case, instead of adding 1, we're adding a fraction, but that's okay. We just need to get a common denominator. So we're going to add 25 over 4 to both sides. Okay, we need to factor on the left. So how do we factor this? Because we have a fraction. I don't know if you noticed, but essentially we're going to get, in this case, x minus, and the number that goes here is the square root of what you have added. So square root of 25 over 4 is 5 over 2. And you always know that this will be a binomial squared. So just as a quick note, anytime you factor, these were easy, we already know how to factor them, but anytime you factor the binomial squared, this number right here is the square root of what you've added. So square root of 1 is 1. And for the first example, really quick, we added 16, and the square root of 16 is 4. So we always, to get this number, we always take the square root of what we've added. All right, so square root of 25 over 4 is 5 over 2, and you can write this out twice, and you can FOIL, and you will see that you get back to this trinomial. Okay, on the right side, right here, I need to get a common denominator. The common denominator is 4, and so I can write this as negative 20 plus 25 over 4. And then we need to simplify. We can now use the square root property, so I'm going to square root both sides. Square root of 4 is 2. And our final answer, we need to add 5 over 2 to both sides. This is our final answer. So again, there are 2 solutions here. And that's it. So we have that for number 3. So we just had to be a little bit careful because we were adding a fraction to both sides and we needed to get a common denominator. Let's take a look at number 4. So number 4 is different because hopefully you see that our coefficient for the first term is not 1. In order to complete the square, your coefficient here has to be 1. So for examples 1, 2, and 3, coefficient was 1, so we just solved it. We just completed the square. Here, the C term is isolated, so that's good. But this is not 1. So in order to make it 1, all we do is just divide by whatever this number is. So this number is 3. We have to divide every part by 3 to preserve the equality. So we divide everything by 3. It doesn't matter if you get fractions or you don't get fractions. You have to divide by 3 because that's the only way to make this coefficient 1. So we have to do it. So if you happen to divide everything here by 3, we just get y squared plus 3y is equal to -3. So that's what we get. And then from here, now this is set up already to do step 3, which is find b over 2 squared. So let's go ahead and do that. B is +3. So that's going to be, I'll write it here to the side, 3 over 2 squared. So that's 9 over 4. Okay, so I need to take 9 over 4. I need to add it to both sides. And again, we're adding a fraction, so you will need to get a common denominator. Okay, now we need to factor on the left, and I'm going to use the same trick. As I did in example 3, the value that goes here is the square root, which is 3 over 2. It's essentially what we're squaring. Right here, common denominator is 4, so you just multiply -3 by 4. We get -12 plus 9 over 4. I just need to simplify that. So when we do that, we get -3 over 4. And at this point, we are going to use the square root property. So we just square root both sides. Since this is -3, we're going to end up with an I on the outside of the square root. And square root of 4 is 2, so I could directly write that. We have that, and then from there I just need to solve for y, subtract 3 over 2. And that is your solution. By the way, if you want, you can, I'll put or, you can also write your answer as 1 fraction. It means the same thing. I can write it like that as well. So it's up to you, whichever way you want to write it. They both mean the same thing. Last example. Okay, so this also does not have a coefficient of 1, so we have to divide by 3. We also have to rewrite the equation because the constant term, which is just the number, is not isolated. So what we need to do is add x to the other side. Okay, so I've isolated the constant term. That was step 1. Step 2, this needs to be 1, so we have to divide everything by 3. And in this case, when we divide by 3, we will get fractions, but that's okay. Okay, so I end up with these fractions. And now our b value is a fraction. So our b value up to this point was always an integer. Now it's a fraction. So this might be where it might be a little bit easier to actually use, instead of b over 2, since b is a fraction, we can write 1/2 times b squared. So this is where you could use this part. Let me show you. So our b value is 1/3, so it's going to be 1/3 times 1/2 squared. So that's going to be 1/6 squared, which is 1/36. This is what we need to add to both sides of the equation. Okay, so now I can factor the left side. Again, when you factor, in this case, it's going to be x plus square root of 1/36 is 1/6. It's right here. Squared. Here, the common denominator is 36. So we have to multiply 4/3 by 12/12. So if we do that, we get 48 plus 1/36. That's going to be 49/12. over 36. That's a perfect square, so that's good. We could take the square root. Let's just write that out. Okay, now we use the square root property. Take the square root of both sides. Don't forget plus or minus. So I have that. This right here doesn't contain any radicals, so we can actually calculate the two values. So what's going to happen is we're going to get x equal to -1/6 plus or minus 7/6. I can calculate what the two answers are. I don't want to leave it like this, like the previous problems. Right, so the previous problems, the answers, we left them in this form with the plus or minus because I can't add 5 and square root of 5. Those aren't like terms. I cannot add -3 and add or subtract -3 plus I square root of 3. You can't combine those, not like terms. But this has no radical, so these are like terms. So we need to write the answer. We don't want to leave our answer like this because it's not complete. So what we're going to do, there's going to be two answers. One of them is -1 plus 7. That's 6/6, which is 1. And the other solution is -1 minus 7. That's going to be -8/6, which reduces to -4/3. And so these are the two solutions in this case for this problem.